All right, so this is the last video we're going to go over for 10.1. Kind of a lot of material here. I want you guys to pause this right now and read through this word problem and until it makes sense. So a huge step in the problem solving process is to understand the problem. So read through it, pull out all the important information. What we're going to do with the information is we're going to find the cost to install 400 square feet of solar panels. Don't forget about the tax incentives. You'll see that when you read through it. The second part is to find a function for the amount of money saved by using solar panels, where T is the number of years that have passed. And then that was B. Part C, find the break-even point for when the panels pay off their original cost. So if you install solar panels into your house, on your house, there's a big upfront cost, but you'll be saving money throughout by saving on energy costs over the course of several years, and eventually you break even, and then they start paying for themselves. You actually are going to save money in the long run. All right, so go ahead and pause and read through it, and then come back and we'll look at each part of this. Okay, so we're going to find the cost to install 400 square feet of solar panels. And don't forget about the tax incentive. So we have a 50% tax incentive, and the government often does this kind of thing because it cuts down on our greenhouse gases when we install things like solar panels. So the government pays for 50% of the initial cost. So how would you figure out the cost? Well, the cost of the solar panels, I'm going to call it C, it's 100, the solar panels cost $100 for every square foot, and we want to install 400 square feet. So if we multiply $100 and that's per square foot, and I'm going to keep those units there because you'll see that this is actually going to give us a total cost. I'm going to multiply that, so that's per square foot, and I need to buy 400 square feet. Put that over 1, and notice that the square feet cross off because one's on the top and one's on the bottom, dimensional analysis. So you end up with a cost of 100 times 400, which is going to be 4 with 4 zeros. That's $20,000. That would be the cost if you had to pay for the whole thing, but don't forget about the tax incentive. So we only have to pay for 50% of this. So we're going to multiply 40,000 by 0.5, which is 50% converted into, if you're going to convert a percent into a decimal, you move the decimal over 2 places. So 0.5 is the same as 50%. So half of 40,000. So our cost for installing solar panels is going to be $20,000. Okay, then the next part is we're going to find a function for the amount of money saved by using solar panels where T is the number of years. So we're going to have a function, we call it f of x. And looking back at some of these numbers here, the cost of electricity. So if you didn't have solar panels, it's 10 cents per kilowatt hour. So it's going to cost us 10 cents per kilowatt hour. And we know that each square foot, so 1 square foot of solar panels, produces 20 kilowatt hours per year. So putting that together and using our units, so look at the units that go with these things. If we take our 10 cents, which is $0.10, times 20, which is, this was 10 cents per kilowatt hour. So I'm going to leave the kilowatt hour down here. Hang on a second. Per kilowatt hour. And then it's 20, if you look back up here, 20 kilowatt hours every year is what the solar panels are going to produce. So we can multiply 20, that's 20 kilowatt hours. So that I can put that over 1. And then I know that I have, and that is, 20 kilowatt hours. Let me go back up here. It's 20 kilowatt. Each square foot of solar, this is the part that you really need to focus here. Each square foot of solar panel produces 20 kilowatt hours every year. So that's 20 kilowatt hours per square foot. So if I keep these units down here, 20 kilowatt hours per square foot means the square feet go in the bottom. And then multiply that by, you have 400, you're installing 400 square feet of solar panels times the number of years T. That's our function. And if you look at this, the kilowatt hours cancel out, the square feet cancel out, and you're just left with a dollar sign. So we're going to figure out the amount of money saved with this function here, and multiplying across, it's gonna be in dollars. I'm gonna leave the dollar sign off though, but just know that that's what the units will be. 0.1 times 2 is 0.2, and 0.2 times 400 is 800 T. That's how much we're gonna save per year. And then, so we're saving 800 every year, $800 every year. But remember, our upfront cost was $20,000. So our savings is going to be 800T times 20,000. And then what we want to do is the part C, we're going to figure out our break-even point, which means we're back to like square zero, and after that point we're going to start saving money. Sorry about that line there. So we're looking for a break-even point. So you might want to grab a calculator for this part. When you break even, this function right here is the amount of money saved. So we want to know when we're offsetting that $20,000. We want to know when our total amount is equal to 0. So we're going to set this 800T minus $20,000 to 0 and solve for T, and after that time we'll be saving money. That $20,000 will have been paid off, and we will just start having free electricity essentially. So to solve this, we're going to add 20,000 to both sides, and I get 20,000 equals 800T, and then you're going to just divide by 800, divide by 800, grab your calculator. 20,000 divided by 800 is 25. So that means it's going to take 25 years for you to pay off the initial cost of solar panels, because we're saving $800 a year, and doing something for the environment. So 25 years down the road, after that, it might seem like a long time, but 25 years goes by in a flash. I speak from experience, it just does. And 25 years after, and anytime after that, you're just saving money. All right.